Oh, hello again. Welcome back to our YouTube channel, Kotlin channel on YouTube, where we talk about all things Kotlin, of course. And this is the last episode in the series of server-side development with Kotlin. And today we have Oleg Dokuka talking about a very interesting topic, in fact, the multi-platform development with Kotlin in terms of not mobile, as it might be surprising for you, but server side development with front end development. So we are going to have a very nice demo on with Spring Boot and Kotlin JS. And without further ado, I'm going to bring in Oleg again. Hey there.
Hello, hello.
Hi there. So long-awaited webinar. We skipped it last week, but we are going to make it this week. And there's a lot of interesting stuff we are going to talk about today. So, Oleg, the floor is yours.
Yeah, thank you. First of all, thank you again for having me at the webinar, JetBrains webinar. The last time we've been there, we have been talking about Kotlin, server side, Spring, and RSocket. We were building a Kotlin and Spring chat application. And this talk is kind of continuation to what we started, except that instead of chat application, we will be building a collaborative to-do list. Collaborative sounds too impressive and too optimistic because after all, we are far from real scientists who are building collaborative tools using real algorithm like CRDT. Our implementation is far simpler, but anyways, we will look how you can build one. And our main focus today will be, of course, Spring, Kotlin, reactive programming, streaming, and RSocket. And this time, a part of RSocket Java, we will look at RSocket Kotlin, which is gonna help us building a real multi-platform Kotlin application. So with that, let's start. I don't have any slides today, and we will be just building stuff almost from scratch. Of course, we won't be building any JavaScript application and any kind of front end related part because it's hard, and I'm not an expert. So um, I just copied some bits from existing to the list, which you can find basically googling and looking at official to do MVC list of implementations, and here you may find one of the just offline first, browser first with no server, Kotlin to the list implementation using React. Um, we just I just taken these bits and kind of copy pasted it and updated them a bit to make it to make them more aligned with what we're going to be building. And technically, you can do the same on your own. That's why we won't be looking into GS too much. But the final application that we will be building looks like that. Um, we can type some messages, and yeah, they should appear at both sides. Of course, we can see that after we type in something, there are some bugs. Of course, there are some bugs. Last minute fixes led to some bugs, but that's fine. Our main goal, again, just wanted to remind you, is to look at Kotlin, how to use Kotlin multi-platform, how to use Kotlin multi-platform with Spring. So that's what we will be focusing. And if you want to learn more about building real collaborative tools, about using real algorithms, as I mentioned, I highly recommend you to where is this tab? Yeah, here we go. I highly recommend you to look at this video from Martin Klapman. He's a real expert who knows how to build distributed collaborative tools like Google Docs and similars. And listening to his talk, you may learn more about collaborative tools itself. But yeah, we won't be building the same thing as he does. We will be looking at Spring. So before we're gonna start, let me open my IDE, and as usual, we have a common uh, similar to Java Spring application, but that time it's Kotlin Multiplatform. And the main difference that you may spot already immediately from the folder structure is that we don't have kind of source main Kotlin anymore, but instead we have a few more kind of source folders. So this is kind of a common style for multi-platform applications, and that's how you will build your own application as well, multi-platform one. And what is pretty standard there is some common shared bits. So every multi-platform application has common shared bits, and we will be looking what we have common there as well. A part of that, since we are building a browser first and server first, of course, application, we have React main, which is for browser front end part implementation of our app, and of course we have something related to GVM, but I call it our source folders exactly as we have our framework. So it's Spring backend, Spring application, and Spring tests. So this is this folder structure, but before we even start doing anything, let's have a look at the most important part of multi-platform application, which is a Gradle configuration or Gradle build file. So in order to you enable multi-platform application and multi-platform capabilities at your app, what you have to do is basically importing multi-platform plugin into your app. So this is how you can do. Of course, there is newer version of multi-platform, and there is newer version of serialization plugin, and we will be talking about serialization a bit later. But this is pretty new and cool feature like 1.5, and there are still some bug fixes and things ongoing to improve the pretty fresh and new version of Kotlin and related plugins. That's why, to make sure that our demo gonna go smooth and we won't be observing any bugs related or things related to new version, but rather focus on building multi-platform application. That's why we are using the most stable version of Kotlin, which is 1.4.32, and all the related plugins to it. So yeah, that's what we have here. And then, as usual, instead of defining common kind of GVM common things, we are defining absolutely new section, which is Kotlin. Kotlin immediately means that this is for multi-platform. Actually, you can use the same keyword even if you are not building multi-platform. For example, if you're using Kotlin for GS, you can define the same section and just declare bits related to JavaScript, like to Node backend server or to like browser front end. But multi-platform by default brings everything that you can build for multiple platforms. And in our case, we are interested in the platform GVM platform in JavaScript platform. And if you wish, you can add more platforms here. Like you can add AOS, you can add for example, like Linux native build, if you wish. So multi-platform build and multi-platform plugin let you doing that. Right now, we won't be doing exactly this. We will be focusing only on GVM and GS. And as you can see, I have already configured something related to JavaScript because, again, this is front-end bits. This is pretty standard configuration of Webpack, if you're familiar with that. And here I configured Webpack to copy some of the generated JavaScript files to some Spring related folders, like to the folder where basically GVM build tried to find resources at the assembling phase, and then from that folder we just copy JavaScript files into our generated jar later on. And then we have sections related to dependency configuration. This is pretty interesting section because since we have some common things, Kotlin lets us define some dependencies which are designed for multi-platform usage. For example, in common main or in common dependency, we can, or in common sources, we can define the usage of Kotlin HTML, and I'll show you how you can build, even from the JVM server-side application, you can build HTML file without using any HTML at all. And then Kotlin datetime, because again, this is something common. We need datetime at both JavaScript, Android, JVM, everywhere. We need datetime, and there is Kotlin X datetime library, which let you use common API for date and time, which is cool. And the last and the most important thing, which is Kotlin serialization. So Kotlin serialization, if you're not familiar with what is Kotlin serialization is a common libraries for serializing your DTOs to any output format. So for example, there is Kotlin serialization for protobuf, and you can just add one annotation to your data class, and here we go. This data class will be serializable. Kotlin will generate some stubs for you, and you won't be messing anymore with anything related to encoding and decoding. You will be just using the native Kotlin X serialization API, and that's it. In our scenario, we are using Kotlin serialization for JSON. The main reason for that is because Spring supports only Kotlin serialization for JSON. And if you'd like to use, for example, protobuf, you would have to mess with some binary things. And probably we don't want to do that right now. That's why we will be using just things which are built in Spring, and that's it. Which is wise. Yeah, of course we are using UID and some other stuff, which is less relevant. We have some configurations for front end. As you may see, we depend on common main branch, which means that we will be bringing everything from common main, everything declared in the sources, plus all the dependencies. We are taking here RSocket. We are taking RSocket for Kotlin. This is pretty cool, bright, new implementation, like relevant. Like it's not super new. It's like 1 year old, I would say. It's relatively new compared to RSocket Java implementation, but this RSocket Kotlin implementation is fully aimed for Kotlin. It's built on top of Kotlin API, nothing from JVM world, only Kotlin Ktor. It's compatible and can be run on the browser, on the native. We have RSocket CLI actually, which is using RSocket Kotlin underneath and compiles itself into native code, and it can be run. You can download it and use at Linux, at iOS. So this is a good example of RSocket Kotlin usage already. And you can use it at iOS. Of course, right now, as far as I remember, we don't have Ktor transport for iOS, so you would have to play a bit with building your own transport for iOS. But you can easily use this library at Android, and there are no minimal kind of Java version because this is Kotlin. You can use it on the backend side if you wish, and of course you can use it at front-end and browser side. And we have proper Ktor transport, which is Ktor client JS, and we have RSocket core, which is just common shared implementation of RSocket Kotlin, binary framing, and stuff, like everything related to RSocket in a few words. So this is pretty common stuff, and I'm saying that this part only declared at the front end side for now, because we already have really powerful implementation of RSocket, which is RSocket Java, which is kind of bundled into Spring messaging. And at this moment, we don't have, and probably we are not planning to support RSocket Kotlin at the Spring side. Maybe in the future with Kofu, if you know what is that. If you don't, please Google Kofu, Spring Kofu. This is pretty cool things related to Spring Kotlin native configurations of Spring and so forth and so on. Really lightweight and powerful applications. But for now, RSocket Kotlin only on the browser side. On the server side, we will be using common RSocket Java, verified by time and fast and performant. And a part of that, we have a couple of front-end dependencies. So at this app, as I mentioned, we are using React. So I just copy-paste everything which was on the official tutorial to the MVC app. And we have React DOM. And yeah, if you don't know what is that, I don't know as well. Please Google for that for me. And that's basically it. So let's quickly have a look at our React main. So this is React application written at Kotlin. So we have app, we have, if you're familiar again, you know what is that, like components, component mount, render, and so forth and so on. Here we have Kotlin, some Kotlin HTML bits, like we declare section, we declare input, attributes. So this is standard HTML React related things. And right now we are not interested in that. So if you want to learn more, there is good tutorial at Kotlin, official Kotlin website, as far as I remember. So if you want to learn more about usage of React, HTML, and so forth and so on, go ahead for this tutorial. It should be helpful for you if you're interested in that. We are not looking into that anymore. What we are interested is basically our client, because we have client interface. This client interface is used for communicating with our backend. Of course, this communication will be done through RSocket. So we will be looking how to implement and how to use RSocket Kotlin API, and you will feel that this is pretty native Kotlin API, and everything is smooth and natural, fit really good into Kotlin ecosystem from the setup perspective. And that's it. So that's what we have here. And we have some shared stuff, which is basically model. Model is basically the data type that we will be exchanged between our front-end and server side. The good thing about shared or common sources that they're common. We don't have to redeclare our API every time we change something on one of the sides. We have common implementations which are serializable. Here we use Kotlin serialization. So this annotation comes from Kotlin serialization, and that's what all we have to do for enabling serialization for a specific class. And we have some other events which are shared. So we have some shared sources which can be used at browser and server side simultaneously. We have some other bits shared as well. For example, imagine that you want to build a CRDT algorithm. As far as I know, at this moment, the one of the libraries supported by Martin Klapman is AutoMerge. Let me find it. Here we go. So this is a library which let you build collaborative tools using CRDT, and this is really powerful and well known and well used library. The only problem that it has is that it's written in JavaScript, and there are no other implementations. Like there is implementation for Swift and for us, but we are at JVM. There is no Java implementation. There is no Kotlin implementation, which is a problem. So we want to build our algorithm, and if we would follow standard practices like building front end like using JavaScript or TypeScript and building backend using Java, we would have to implement this algorithm once, or even more, twice. So once for our backend for Java, and then we're going to start building, for example, I don't know, Android, and then Android will be at Kotlin. So we would need to somehow port the same algorithm to Kotlin. And then, I don't know, imagine that you want to build for other language like Python, and there is no Python API, or there is no other language API. So with Kotlin, this problem is basically solved because Kotlin can have shared sources. These shared sources can be compiled to JavaScript, can be compiled to JVM, can be compiled to Swift, which is really powerful. And then you write once single algorithm, and this algorithm is shared, it's tested, and you know that it works. It just works on all the platforms. This is really powerful about Kotlin Multiplatform. And we have here similar bits. So we have repository. So repository is basically the thing where we store data. And the repository cannot be shared because, for example, at browser, we want to store information at local storage, like browser store. At the backend, we want to use database, which is not available, for example, at frontend, right? So Spring can be easily connected to H2, to Postgres, whatever database you use. And this is something that we would have to implement on every platform separately. Fortunately, the service logic or the algorithm logic can be shared. And this is a good example how we are sharing our common bits. So we have some logic related to events handling, some storage, restorage, like restoring some events and so forth and so on. So here is a small example how you can implement one algorithm and use it everywhere. So this is a really important message. Think about it, because if you wanna reduce the number of bugs, and believe me, if you write implementation for multiple platforms, and I know how to do that because at RSocket and as RSocket member and as RSocket team, we are building multiple implementation for Swift, for Kotlin, for JVM, and now we have to re-implement the same thing again and again and again. Unfortunately, with Kotlin, you can technically reduce the number of bugs because if you put more effort into RSocket Kotlin, you can use it at multiple platforms, and this is a way to reduce the number of bugs. So the same here. Use one service, define it in a single place, and use it everywhere. So this is the rule with Kotlin Multiplatform. All right, so this was a short intro into what we have, and now we wanna start building the real logic. So as I mentioned, we wanna have Spring at the backend, but at the moment we have 0 Spring dependencies here. So you may wonder, okay, how can I port Spring application into Kotlin Multiplatform? Because there is no generator for Spring app applicable for Kotlin Multiplatform. Fortunately, don't be afraid. What you have to do, you have to go for start.spring.io, and you can generate your project as usual. So you can add your, for example, RSocket dependency. You can add your webflux dependency. Oh no, not Spring Web. I don't want to have Spring Web. Spring Web is blocking. We want to use fancy reactive non-blocking web. Yeah, reactive web. Of course, you may add like reactive data store, but we don't want to mess right now with data store. We will create in memory one, and that's it. And once you added all the dependencies that you need, once you specified your version, you can click explore. And what you have to do, you just need to copy these plugins like this. So I'll be just copying them here. Of course, we would have to unapply them because we don't want to have Spring at the browser side, right? It won't be running, and of course, we won't be able to compile it here. Apply false. Apply false. We don't need JVM because we are using multi-platform, and JVM is enabled by default here. And we enable JVM by defining the JVM section here. And once we brought our plugins, what we would have to do, I'm lazy, I'll just roll back what I had here before. We would need just to apply those plugins exactly at JVM section of our multi-platform setup. That's what we would need to do. And then you can just easily copy the rest of the things. Like, for example, if you need to have some task, you can just copy it like here. Nothing has changed. You can apply specific task to specific platform, and they won't be kind of causing any problems for the others. Just want to emphasize your attention that if you just copy these things to and put them globally, you will probably fail because there is no Kotlin compile for browser. There is task, but not everywhere. So be careful about all the tasks since they are applicable only for specific platform. Now, all right. So what else do we need? We need dependencies, and again, fortunately, we can copy dependencies as is. This time, we would have to, yeah, we would need to specify actually the Java, or we don't. No, we don't. Probably we don't. We have already specified it here. JVM target, yeah, I'll get it here. So we need just to copy dependencies. And in order to define source set for your JVM, you have to follow the same guide. So if you, for example, specified name like I did, like Spring, your source set will be called like Spring main by getting. I don't know. This is just a pattern. I'm typing as it is everywhere. I have no clue what is getting actually. You may, if you know multi-platform more. I'm just learning these bits, and I'm sharing what I learned with you. And that's basically all the setup. So you specify Spring main, you bring your dependencies. There is no test implementation. So if you want to bring some test dependencies, you have to separately say, okay, Spring test. And this is going to be as defined and recognized as test sources. And then here you can just define, for example, depends on common test, and then implementation, and that's it. So right now we just set up everything that we need for Spring. We just set up everything that we need for Spring tests, and we are good to start writing some code. So do we have any questions so far, actually?
No, not yet. But the only question was why your face is frozen. It seems that we have some connection issues again. But we can hear you pretty well. It's just that your face on the video is stale.
Okay. Let me reshare everything again, so we don't have any problems. And let me stop and start my camera. Let's see. I don't know what's wrong with the video.
Let's keep it without the video. It seems well. At least we can hear you pretty well.
Okay, you will see my frozen face. All right. Can you see my screen now? All good?
Yes.
All right, perfect. Maybe something related to the browser. But anyways, let's continue. We have set up all the dependencies, and now we can start coding a pretty normal Spring application. I have already prepared some kind of patterns for us. So we have controller, we have repository, we have folder for configurations. We can start right away from defining controllers because this is the most familiar thing for us. What we're going to be doing, we will define index controller here. And what we want to have here, oh well, I defined a Java file. My bad. Bad pattern, or bad practice, bad habit. So let me define Kotlin file, index controller. Now we put pretty standard annotations like controller, still indexing. I don't know. This is idea, like it like to index everything, like the whole world, but okay, Spring test, for some reason it doesn't work. So yeah, let me just roll back what I had before just to make sure that it works. Yeah, probably I missed the dependency section. Okay. And in the meanwhile, we will be typing stuff. We have controller. We want to define the same request mapping, or better, get mapping. We don't want to specify separately. Message mapping, we want to define function called index. And here, what we want to do, instead of like sending a link to HTML file and using standard Spring capabilities for resolving your template and so forth and so on, we wanna write a way, build our HTML file using Kotlin HTML and send it as a message. So in order to send our content without changing anything, like without saying that we want to look for some template or view first, we want to say, okay, response body. If you don't remember what is response body immediately says to your controller that the response from here is the actual body of your message, like of your response. And then we want to use some features from Kotlin HTML. So in order to oh well, perfect, exactly on time, we got everything scanned. So I'll import all of the dependencies. So we define just normal get mapping, and now we have to somehow build our HTML. Fortunately, with Kotlin HTML, everything is easy as pie. So what you need to do, you need to use just one function, create HTML. So this will generate HTML body for you, and then within this HTML body, you can define the other things. For example, you can define head, and within head, you can define, for example, some links to like CSS files, to your, for example, you can define your title, right? You can define your title. As far as I know, this is a function. I'm not sure. Again, I don't remember all the bits. And the same way you can define body, and you can say, okay, I want to define div here and so forth and so on. So instead of messing with all this import, I'll just put my prepared, not this, I'll just put my prepared template. Come on, why open this window? I don't want to open this window. KTX index HTML. Here we go. Yeah, I forgot HTML declaration. And then everything almost as I explained to you. Well, let's do something like this to reduce the number of declaration, and we are good. So we declared basically our HTML. And as you may see, there is nothing complex. The declaration itself looks like real HTML. The only difference is that it's defined in Kotlin. It's type safe. You can use all the tags that are defined in real HTML. And for example, here we are referencing to some JavaScript file generated by Kotlin JS. So let's run this app. This is going to be the first step that we will be doing. Let's just run it. It's gonna take some time. First of all, oh right, I forgot to do some extra things. Of course, it won't be working because we need to implement some other stuff, and it won't be working because, oh well, we have this task which is copying some, or which is providing the dependency or building dependency tree for copying stuff into Spring resources. So all good. It won't be working because exactly of this dependency. So let's disable it for now, and let's try to run our Spring app just to see that that our HTML is really rendering. That's what I want to show you. So let's go back to our browser. Not there, and not even here. So let me close this window. We don't need it anymore. Yeah, to this one. So we reloaded our application. Of course, nothing is there. We can put some hello world stuff here. For example, we can say span hello world. Yeah, it should be like that, or we can use p.
It should be just plus,
Yeah.
I think. Yeah.
Oh, yeah, indeed. So if we're gonna restart it, we should see some hello world. Yeah, hello world. Perfect.
Perfect.
Yeah, we have it. So you see that you can easily build with Kotlin your real HTML and there won't be any problems. And it's really transferred as HTML. So yeah, believe me if I say preview hello world. Perfect. And now we want to take some real bits of React app here. So we start with the simplest thing. We define it index HTML. So now we have to quickly go to React side, and we need to define missing bits, because here, in order to enable React application, we need to have implemented some shared things like storage for our repository. So don't worry if it's a bit clunky and we are jumping from one to another side. We need to implement these beats because we want to compile. We want to make our front end compiling. So at least we can define this local storage as a class for now, just for beginning, and we can make it extending to the repository. We can implement all the methods with to-dos. So this should enable compilation here, shouldn't it? Okay, I did some typo here. So now we're good. Let's make it compiling. And now we can try to enable this task back and try to rerun our application and see that our JS file is really compiling, and we see the output on the browser end. So while it's still compiling, let's continue with our Spring side. So we define a just index HTML file, but a part of that we want to use some Spring related things. Okay, the Spring app is running. Let's reload it. Okay, nothing is on there. Yeah, we see that our main JS is coming in right now, so all good. It's working, which is something that we wanted to see as well. So now we want to define some Spring beats. As I mentioned, we will be using RSocket here. So RSocket is a network protocol. If you don't know what is that, it's like application level protocol. It's similar to HTTP but brings much more features. So it's first of all transport agnostic, which means that you can run it on top of TCP, you can run it on top of WebSocket. And in this scenario, we will be running RSocket on top of WebSocket. Main features that it offers is multiplexing, bidirectional peer-to-peer communication, so you can easily call server from the client, as well as your server technically can call you from its side. So we will see how to do that as well. And this is just a standard and pretty popular. It becomes popular to wire your communication on the edge between your like mobiles, browsers, and your servers, as well as it's pretty popular within behind the firewall. So if you want to enable communication between your microservices, you are not limited to HTTP anymore. You can easily use the same protocol like RSocket with the same framing, but run it on top of like Aaron. Or shortly we will have Quick, so you will be able to use Quick even though there is no standardized API on the browser. Quick will be enabled at your server side, and then once Quick will have a standard API for browser, you will be able to use Quick as well, and you wouldn't have to rewrite the whole application just because you want to move to Quick. And remember that Quick won't be supported at every browser, right? Edge probably will be the last one to support it. Of course, I'm joking. I don't know, but all the front-end developers messing with compatibility between different browsers. WebSocket is working in that browser. It doesn't work in this. It works at this version, but it doesn't at this. So there is a lot of mess. RSocket helps you to solve it because it's transport agnostic. WebSocket doesn't work, Quick works, please use Quick. Quick doesn't work, WebSocket works, please use WebSocket. So this is perfect solution for all the scenarios. And we want to use it with Spring. With Spring is like setup of RSocket is easy as pie. So what you have to do, you have to just configure some configurations at the property file. So for example, you want to say, okay, nah, not that one. You want to define your transport. RSocket transport. Where is that? Server on. Yeah, transport. And we want to use WebSocket. And then WebSocket, since this is HTTP, technically, it's enabled through HTTP. It has to have some HTTP mapping. That's why we have to define RSocket server mapping path. And we can say, okay, we want to handle all WebSocket related to RSocket connections at this /RSocket path. So that's technically what all you have to do in order to enable RSocket. It's fully integrated with Spring Webflux, so you will be able to run Spring Webflux at the same time with RSocket, and there won't be any conflicts at all. And in order to set up your RSocket controller, you don't have to learn anything new. So it's the same as it was before with Webflux. So for example, let's define to do controller. Okay, I created Kotlin class, which is progress, right? And what you need to do, you need to say controller. Here we go. That's all you need to do in order to enable RSocket on the Spring side with support of Spring messaging. And yeah, that's basically it. Then what you need to do, of course, you want to have a couple of methods. For example, you want to have a method to handle, for example, to-dos. Your browser probably wanna send some messages, some changes, some additions from its side, and you want to handle them. So if we're gonna look at our client API, we will see something like add to do, update to do, remove to do, and those actions like API calls are executed in the scenarios where we created new to do or we removed to do from the list. And this information should be shared because we wanna enable like collaborative to do list. So we need to somehow exchange this information and exchange it in real time. And this is something important and related to RSocket as well, because this is near real time or almost real time communication protocol. Of course, there is network latency. We can't do anything about it, or we can do nothing about it. That's why it's near real time. But it allows you to exchange messages between peers, and you can kind of build your server as a broker. That's what we will be doing actually. What we wanted to look is the API, and our API says, okay, add to do, update to do, remove to do, and we will be handling these messages somehow. We will think what type of communication channel we will use, but let's define a controller and we will figure it out. So we want to say, okay, handle to do. It's clear that all of the handlers or all of the kind of calls, API calls, are pretty similar. As you've seen, all of them has this to do kind of to do pojo or to do object. So what we want to do, we want to say message mapping. We want to say to do again. It's the same as you've been doing before with HTTP. The only difference is that HTTP has request mapping. RSocket has message mapping because this is print messaging kind of API or annotations. And here, what we want to do, we define kind of to-dos as an API, and then we want to somehow distinguish between like add, remove, update, and so forth and so on. So technically, we can write down something like this. We can create one handler for adding messages. We can create then another for update, and then another for remove. But this sounds to me a bit redundant, right? We opt for simplicity. Unfortunately, with Spring API, we can define some end matcher. We can say, for example, action, and then this action can be easily recognized by us separately and transform into specific, for example, action in our business logic. So that's why we want to just define handle to do. We want to handle incoming message. In order to handle incoming message, you have to use payload annotation. Then we want to define our actual message, which is to do. We want to figure out what type of action we received. So we want to have similar extractor from the path variable, which is called destination variable. It's called our one is called action, which is gonna be a string. And yeah, for now this is all we want to have. So let's say that we don't want to return anything, and probably this execution has to be suspended because we will be doing some stuff with coroutines as well. So let me see. Okay, yeah, I forgot to put fun at the very beginning. All right, we wrote down our handle, and then I won't be spending much time, so I'll be just saying, okay, when action blah blah blah. We will be writing some stuff here. Of course, I won't be wasting time. I'll put just a template here, and then we will use some common shared things from our common main. So we want to use our to-do service because to-do service brings our business logic. So we want to import basically our val to-do service. And once we received our message, we want to call our handle event. Handle event allows us to process any type of incoming event. So what we have to do within when we have to transform incoming action into enum, but this is going to be a separate task. So what we want to do right now, just to draft out what we will have in our business logic, and then we will just fill the gaps afterwards. So let's put add, and let's create to do event. And yeah, it should be like this. And our to do message here, not like this, but yeah, like that. So this is going to be initial bit. What we've just done, we stored, we propagated our event to our business logic or our algorithm. Our algorithm will put afterwards some stuff into our repository, so we will have persisted all of the events and all of the to-dos on the backend side as well. So we will have multiple source of truths like browsers and of course server side. And then after that, we need somehow to set up message exchange, because we just received a signal, and now this signal has to be broadcasted to all of the connected clients. So with RSocket, again, we can have it, because RSocket is and with Spring messaging, we have peer-to-peer communication, and we can handle all of the connections, and we can store them somehow, so we will be able to deliver messages to all of them. So what we want to do now, we want to write some connection mapping here. Let me just put a template. Connection mapping let you handle connection phase. You can receive your connected client. Your connected client is exposed as RSocket, so you can technically send some messages or request some data from browser or any connected client. We want to generate some identification ID for our client, and now we want to store the information related to our client. So we would need to create a couple of stores. So we would need to create a store for our clients, which is going to be concurrent map. Right, we are in the GVM, so we can use some GVM related classes. And this is going to be our socket requester and concurrent hash map. So we store our, it should be not string, it should be probably UUID. And then we need somehow to wire up broadcast logic. How you can do that? If you've seen our previous stream, if you haven't, you have to see our previous stream, or you have to look at our Kotlin and Spring tutorial. We've been looking at that. In order to create some broadcast logic, Kotlin Coroutines offers us a pretty good class called Mutable Shared Flow. So Mutable Shared Flow is basically a wrapper around coroutine, like it's technically a buffer to which you can send messages, and then the subscriber to this kind of queue or buffer can subscribe to it through Flow API. So Mutable Shared Flow is from coroutines, is from Flow API, and then we will be returning this shared sync to our connected client, of course. And we need to store this shared flow again, because every flow should be associated with a particular client. But instead of RSocket requester, we will be using mutable shared flow API, and we will be sending and broadcasting some to-do events through it. And yeah, probably we don't want to use UUID. We want to use RSocket requester as identifier, because we can get RSocket requester from any point on our message handling. So Spring allows you a part of like getting payload, getting, for example, some headers or path information. You can say, okay, I want to get information about my client, and just by defining this parameter, you will be able to get access to the client who sent the request. Again, we have this information because we have single connection, persistent connection, and every client is associated with particular connection. So it's not a problem to identify from which this message comes from. Unlikely with HTTP, this is a huge problem. That's why you have to mess with JWT tokens and so forth and so on. With RSocket, you can authenticate once, connection will be opened, and everything within this connection will be secured, and you will know from whom from which user it comes from. So we want to do the same. We want to get RSocket. We'll be using RSocket request. We'll be using this identification later. We also need to define one extra method, which will be broadcasting all the events. So once our client open connection, it will say, okay, I want to listen to all the messages from all other clients, and we need to define an endpoint for that purpose, and this should be a streaming endpoint. So if In this case, like handle to do, this is just request response. We send a to do and get technically nothing back. So it's even fire and forget. With broadcast scenario, we want to have a continuous stream of messages, and continuous stream of messages can be represented through flow. So we define flow. We say to do event. And what we will be doing, of course, we need to understand who is calling us right now. And by understanding the caller, we can do something like streams, and we will be able to get a particular associated mutable shared flow and return it from here. It's still complaining. It's complaining because concurrent map doesn't guarantee that value, that returned value is not nullable, because this is a port kind of conversion from Java to Kotlin API. That's why we have to force it return non-null value, because we know that this action happens before this one, so we should be good. It's still complaining what it says. Not type argument expected for class flow. Probably I'm using the wrong flow. Of course, I'm using the wrong flow. Let me re-import it. Come on. Kotlin cartons. And now we are good. So we are getting our particular associated this particular user flow, in which we will be sending messages from the other users, and we return it. And in order to enable streaming, you don't have to do anything more than just saying mapping and defining a path for this mapping. That's it. You're good. You define your endpoint, and this endpoint is streaming endpoint. So you can continuously send messages, and your client will observe them. All right, so we are almost done. Just to finalize the story about handling new collaborators, we need to discover that collaborators has been disconnected, and we have at RSocket level on close method, which let you kind of listen to disconnection events. And once client is disconnected, what we want to do, we want to remove this client from the list, and we want to remove associated stream with that client as well. So this is kind of cleanup action. So we won't be sending messages into void, because this can lead to some bugs, of course. It still complains. All right, yeah, because it wanna have our socket requester. Right. What is left is our to do handler. So what we want to do once we got our to do, we want to start broadcasting our incoming event. So how can we do that? We have a list of all the clients, of all the streams, all the listeners, and we can technically just say, okay, for each listener, just get it and say emit streams. Come on, it. Yeah, it's a stream entries. We want to iterate over values, and we want to say, or we are good now. We are good here. Value dot emit value, and we want to send the incoming to do. So probably we want to store this to do event into variable do event. Want to use it here, and we want to use it there. So this is how you can easily broadcast all the events to all the connected clients. So what we've done, we just created a broker, and once one of the client gonna send a message, this message will be propagated to all the connected clients, and all the clients will observe the change, which is cool. So this is not a huge job, right? We haven't wrote down we haven't written down a lot of code. This is what we've done. The only thing that we wanna we want to have is we want to ensure that the message won't be kind of echoed back to the same sender. So what we want to do, and that's why we basically imported this RSocket requester, we want to filter ourselves from the list of active clients or active listeners. And if we see that the requester key is not equal to RSocket requester, the actual sender, then we pass this listener. So in that setup, we will be sending messages only to other clients, and we won't be kind of listening to other messages and again. So we won't get into this deadlock or infinite loop. Yeah. So I don't want to write this transformation logic. Of course, you know that with support of when you can easily iterate through like with pattern matching, but in Kotlin you can iterate through different scenarios of action. I'll be just entering the prepared template or not. I'll try to restore it from Git history. Yeah, perfect. This is event type, so now we want to replace event type here. Put event type there, and then propagate event to all the listeners. Perfect. That's what we want to do right now. Did we miss anything? No, probably we don't. Some logs, but this is minor. Yeah, we missed some configuration. So we clearly see that to-do service doesn't have anything. So let's quickly define our configuration. This is the last bits, and then we will run our application again, and we'll see that it should work, at least. Of course, the front-end bits isn't implemented yet, but this is minor. So we want to define app configuration and Java file. My bad. Habit. So Kotlin file app config. Let it be app config, whatever. Pretty familiar configuration. Bin fun to-do service. For to-do service, we need what? We need to-do repository. So we need somehow to outwire this to-do repository. This is another task. But in general, let's put it like this: to-do service, then to-do. So in general, as you can see, even though we are building multi-platform app, nothing has changed from normal Spring Boot application development with Kotlin. And even though it's written with Kotlin, it still has the same convenience, same annotations, same stuff. Nothing has changed, even though you are in Kotlin, you are in multi-platform environment. So just don't afraid and use multi-platform and build your multi-platform apps today with RSocket. This is important. You have to use RSocket. So what is left is repositories. So we are quickly, not Java, Kotlin. In memory, we're going to define some in memory to do repository. Again, I don't want to write all this stuff. I just use my magic templates, and I'll put the whole source code right away. So we have to import a few more things. And to do. Perfect. So we have just implemented repository. And do you see this magic annotation repository? Yes, it works even if you created your own class. And this class will be treated as repository. And this annotation, if you have never knew about it, it's just indicator from domain-driven design that this is your repository, it's your data layer. This is pretty cool to put these annotations to distinguish between your different layers, because every one of us got used to just saying components, but this is less convenient to me. All right, so we define our repository. We configured our to do service. We created our controllers. We created our index controller for getting HTML, and we created our to do controller for handling incoming collaborators or incoming connections, for handling their subscription for listening uh, from other collaborators. So that's how we broadcast, again, just emphasizing, that's how we broadcast messages from every client. And this is a handler for incoming kind of request response from the client. So client request, send a request with some to-dos, with some changes related to that to-do, and we just parse what type of action is there and broadcast this action to our store. We are using shared, again, this is shared code, shared business logic between browser and server. We are using this business logic to store event in our local repository, to persist this information, to have a replica at the backend. And then we broadcast all the messages. And what you have to write down in order to create a broadcast logic is something like this. Easy. Okay, so let's run it. And while it's compiling and doing some stuff, let's go back to our front-end side, and let's work a bit with RSocket Kotlin. So what we have to do at the client side, we have to wire an RSocket connection to our HTTP server. So for that purpose, we have like a static method create. At this static method, we will try to write down some RSocket Kotlin logic. Yeah, and basically what you have to do, you just have to use, you don't have to use like anything from RSocket Kotlin. What you need to do in order to start using RSocket, you have to use Ktor. That's the API that you need first. So we need HTTP client. We need to install WebSocket. It's called, I don't remember actually. Is it WebSocket support? Yeah, it's just WebSocket.
I don't remember myself. Should be WebSocket.
Yeah, WebSockets.
No, it should be just WebSocket.
No, it's WebSockets. It's HTTP client feature. We need WebSocket because this is the only way today to use RSocket, and to create persistent connection between browser and server, like real-time connection, because HTTP is not real-time. It's not bidirectional. You can do the same with WebSocket, but you would need to, without RSocket, of course. You can do anything on top of WebSocket, but with RSocket, it's more convenient because RSocket brings all communication and application features, like, again, multiplexing, APIs, and points, and it's easy to use from Spring, as you have seen, just have seen. And in order to install RSocket, you need to just say install, and you have to call RSocket support. Here we go. That's all you need to do. This part is from Ktor, this from Ktor, this from RSocket. So we put this setup into variable, HTTP client, and then you can call RSocket, and you can specify, for example, your host, which can be anything, localhost. And then you can specify port. And this API comes exactly from HTTP client. So we have extensions to Ktor HTTP client, and we know that through Ktor HTTP client, we usually create only WebSocket connections. That's why the thing that you have to define here is host port, which can be 8080, and path, which is slash RSocket. For TCP connection, for example, if you're using RSocket at the native platform or at the server-side platform, and you want to use TCP transport, you will have slightly different setup. Like it's gonna be similar. You will start from KTOR. This is the core. This is a foundation for RSocket Kotlin, and then you will just say .rsocket, and you will be able to stop the rest of the things. So that's basically what you have to do. You get after that you get RSocket, and if you've seen my talks about RSocket before, you probably know that there is few communication patterns like request response, request channel, like bidirectional stream. Fire and forget, this is just a way to drop a message to network and doesn't wait for any response from the server side. Request response, if you want to get some response back, and request stream, that's what we will be using in order to get real-time stream of the broadcasted changes from the other clients, from the other browsers. Again, this is pretty convenient thing. I won't be implementing all of that from scratch. Again, I will use my magic shortcuts just to put our socket client, prepared our socket client implementation. What I want to show you and what I want to stop on for now is I want to show how easy it's to use our socket Kotlin in Kotlin environment. We have extensions to everything. We have extensions for routing, so the experience is similar as on the Spring GVM side. You can easily define your routing. You can add more information to your composite metadata, which is basically headers, representation of headers at RSocket binary headers, not text headers, but binary headers. You can put any or send any data using Flow. We are built on top of Flow and coroutines. Again, want to emphasize this important point. We are using Flow APIs for handling and doing transformation. And here, a part of just working with RSocket, we are working with Kotlin serialization. So we just say JSON, decode from string, specify decoding type, and here we go. We got our message decoded. The development with Kotlin, with RSocket Kotlin, with Kotlin Multiplatform is easy as pie. Of course, there is some caveats and pitfalls. I probably won't be talking about them because this is improving over time. All the experience is getting better and better, and even now it's pretty awesome, I would say. So let's just move on. In order to use coroutines, unfortunately, we wouldn't have to use a bit of hooks on the GS side because React doesn't support suspend function everywhere. That's why we would need to use main scope, and main scope underneath is using basically browser event loop. So what you are doing here is identical to what to if you just create a sync function which is going to return promise, and this promise won't be kind of handled. So we run some asynchronous tasks, and we hope that they will be completed successfully. What else? So yeah, this is all we have here. We want to finalize the repository implementation. I won't be stopping on that much here. Not that one. ATX. The browser repository. So the only difference with the version on the server side is that we don't have concurrent hash map here. We don't need concurrency here. We are on the even loop, and we are using our local storage to store all the information inside our persistent browser store. So that's what we do here in addition. So this application is offline first, and just in case you're going to store something without having RSocket connection to a server, this information will be propagated to your server and to other clients afterwards. So this is basically it. Let's try to run this application and see that it's working. It compiles. It takes some time because it compiles and generates JavaScript, but yeah, we have it started. So let's switch to our browser, and here we go. We have our to-do list. Let's try. Okay, everything now from scratch. That's fine. We have some bugs. That's
It
okay.
almost works.
It
It
almost
runs
works. Yeah.
and it compiles as well.
And it updates information and once we have typed in something. But
Yeah.
probably something related to React setup. We need Redux here because Redux designed for
Yeah.
storing information properly, and yeah, it's a convenient thing
Well,
for
we
React.
can
But
we can we can promise that we will fix the bugs later and publish the tutorial.
yeah, indeed. So far, let me summarize what we've just done here. First of all, we looked at how you can configure multi-platform Gradle setup. You've seen that so far there is nothing complex. To say JetBrain folks improved significantly the general experience of multi-platform usage, and now everything is as easy as pie. So you don't have to mess with different plugins to support native, to support multi-platform and different builds. Everything is in a single place and can be easily configured. You've seen that in order to make Spring work in this multi-platform, you don't have to do anything beyond just using normal Spring. And we started with start.spring.io. We copied dependencies generated by this generator. We put them into a GVM section related to multi-platform setup, because now every kind of platform has its own dependencies, and this is important to remember. And every platform can have its own like plugins and tasks and so forth and so on. So what you had before with Spring, now just the same, but in a specific GVM related section. For client and for browsers, you can have GVM clients, you can have Android clients, you can have even iOS clients with shared code and with Kotlin code, and you can use RSocket here as well. Again, just emphasizing that. There is some challenges for iOS, but for Android, you definitely can use RSocket Kotlin, and it's, I would say, production ready. I don't know how many companies are using and how big they are, but I know that some of them are using RSocket Kotlin already for Android. And yeah, that's basically everything that I wanted to share with you.
Awesome. So the folks are pretty happy about the demo here in the chat, and of course there is a question like whether it's the technology is stable or not. So the demo we were demonstrating today was based on the stable versions, like the previous versions of Kotlin, of Spring Boot. What else?
Yeah, in general,
K2 or RSocket and so on. So we took the previous version, not the latest ones.
yeah, yeah, the 1.4.32 is stable enough to use it. I believe Ktor team is improving some coroutines integration. So at the at the RSocket Kotlin integration, we will migrate to 1.5 pretty soon. I believe in the closest weeks. So we will update our tutorial and our example application as soon as it's going to be done. And in general, like from the front end side development, you don't have much problems, because if you wish to define or bring some npm library into your application, it's not a problem. There is some specific like Gradle API. You may define implementation to taken from npm, and then Gradle will install everything that you need from npm. You can bring any kind of JS dependency, and you can write down typing Kotlin typing on your own. It's not like something really complex. I tried to do that for Redux Sunk, but yeah, after all, we decided to give up with Redux because It's too much to bring into this simple demonstration. It's enough, already enough of front end bits in this example to get lost in it. So we just kind of limited ourselves in React and RSocket Kotlin. But in general, front end development is pretty straightforward. Android development is as easy as pie, and I guess the most tested and battle proven as of today. So yeah, just try it and share feedbacks with your feedback with us, I would say.
Awesome. So with this, we are going to wrap it up here. And folks, if you haven't subscribed to the video to our channel yet, you should, in order not to miss the videos, the new episodes, the announcements, and all kind of videos we are publishing here in this channel. With this, I'm going to say goodbye to you today, and have a nice Kotlin.